Okay, in this video we're going to be talking about how to find local maxima and local minima of a function by looking at its graph. Okay, so the value of the local minimum or local maximum is the y value. Okay, and where it occurs is the x value. Okay, and if it is a local minimum, that means like this is a local minimum because locally, just in its general area right here, it is the lowest point in this area. Okay, so this is a local minimum. Right here we have a local maximum because in its general area it's higher than everything else. Okay, so it's a local maximum. And then again we have another local minimum here because in its general area it is lower than everything else. Okay, so let's do local min first. Local minima. Okay, so the first local minima is going to occur at x equals 3, or x equals -3, excuse me, and another one at 4. That is where they're located. Okay, they're located at x equals -3 and x equals 4. The value of the local minima Okay, so at -3, we go see what's the value there. So we go to -3 on the x-axis, and where the graph is at is 1. So the value of the local minima is 1, and the other one, we go to 4, where our other one is, and the value of the local minima there is -2, respectively. Okay, so you could say y equals those if you want. Okay, now let's look at local max, or local maxima. Okay, so there's only one in this one. Okay, the only local maxima is this one. Now these, you might be thinking, well, these are higher. How can this be a maxima if these are higher? Well, these have no endpoints. Okay, so these would be absolute maximums. Okay, they you assume they head towards infinity, but local maximums have to be within the graph, not something headed towards infinity. Okay, so located at x equals 1, and the value is y equals 3. Okay, let's look at another one. So on this one, let's look for our local min first. Located at where? Okay, so for minima, again, this going down to -infinity and going down to -infinity, those are not local mins, those are absolute mins, so we're not going to pay attention to those. This is the only one that is locally lower than everything else. Okay, so you look around this point, it's the lowest point around, right? Okay, so it's located at x is equal to -1, and its value is y is equal to -3. Okay, and a local max located at, let's see, we've got one at -4, x equals -4, with a value of 3, and located at x equals 2, with also a value of 3, of y equals 3. Should have wrote that on the last one. Okay, let's do one more example. I think local min and max. Okay, so for local min on this, located at, let's see, there's two different ones. Okay, so at x equals 0, this is a local minimum, and this is a local minimum, so 0 on the x and 4. Okay, so 0 and x equals 4, with a value, let's see, they're both the same, right? -2, -2. Okay, so y equals -2. And then our local max located at, there's two of them, so I'm going to put this twice. X equals where? Okay, so here's a local max, that's at x equals -2. And here's a local max at x equals 2. So -2 and 2, and it looks like they both have the same value. The value of those is y equals 3. So the value y equals 3.